Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's the problem for today. Prices for a 6-month 60-strike European up and out call options on stock S are available. Below is a table of option prices with respect to various H, the level of the barrier. Here S of 0 is 50. So up and out means that as the price of the stock rises to these levels, if it reaches the barrier level, the option is out, it goes out of existence. And the levels are 60, 70, 80, 90, and infinity. And of course, infinity means that, well, it will not get there. So this is with the barrier of infinity, this is just the regular call price. Consider a special 6-month 60-strike European knock-in partial knockout a call option that knocks in at H1 equal to 70 and partially knocks out at H2 equal to 80. The strike price of the option is 60. And here's a table that tells you how this option works. So if the H1 barrier level is not hit, the payoff of the option is 0. Now once H1 is hit, if H2 is not hit, then the payoff is 2 times the maximum of the price of the stock minus 60, but that maximum is normally the payoff of a call option, but it's knocked in at this level H1, and it's twice the regular call option payoff. And then at once H2 is hit, the payoff drops to one maximum of the stock price minus 60, which is the payoff of a regular call. So a portion, in a sense, of the payoff is knocked out at the barrier of H2. Well, I shouldn't really say knocked out. It's taken away, in a sense. Calculate the price of the option. And the reason why I don't want to say this is that I don't want to force this to be a knockout option where I may be able to calculate some other way, and you'll see in just a moment. First, let us go over the concept of a barrier option. The barrier options have payoffs that depend on whether the price of the underlying asset has reached the barrier over the life of the option. So these options can come into existence, and then they're called knock-in options, or go out of existence, and they're called knockout options when the barrier is reached. For the knock-in options, if the price of the underlying asset has to fall to reach the barrier, the option is called down and in. If the price of the underlying asset has to rise to reach the barrier, the option is up and in. For the knockout options, if the price of the underlying asset has to fall to reach the barrier, the option is down and out. And if the price of the underlying asset has to rise to reach the barrier, the option is up and out. Now the option payoff in this problem, after H1 is hit, but H2 is not yet hit, is equal to the payoff of 2 regular up and in calls with strike price of 60 and barrier H1. But after H2 is hit, the payoff of 1 regular up and in call with strike price of 60 and barrier 2 is subtracted. So you could say that the portion is knocked out, but the actual option is the payoff that you see there is a payoff of a regular up and in call, 1 only, while it was 2 before. So the price of the call, that the option in the problem that we're looking at, which is a complicated call, but it's a call, is 2 times the price of an up and in call with strike price of 60 and barrier H1 minus the price of up and in call with strike price of 60 and barrier H2. And you may say, well, it's a different barrier, but it's the same strike price. So what you're subtracting is exactly the payoff of that up and in call with strike price of 60 and barrier H2 upon reaching the barrier H2. But we are only given prices of up and out calls, not up and in calls. So in order to work with the information we have, we need to recall this important identity, assuming the same barrier level, that knock-in option plus knockout options is option is an ordinary option, because if you activate and cancel, then ends up being the same. Cancel each other out, basically. So in the first table, the price of an ordinary call with strike price of 60 is given as the price of an up and out call with barrier of infinity, and it equals 4.0861. And I mentioned that already. The price of up and out call with strike price of 60 and barrier H1 is 70 is from the first table 0.1294. The price of an up and out call with strike price of 60 and barrier H2 equal to 80 is from the first table again 0.7583. So the price of an up and in call with strike price of 60 and barrier H1 equal to 70 is the price of a regular call minus the up and out call, and that's 4.0861 minus 0.1294, so 3.9567. And the price of an up and in call with strike price of 60 and barrier H2 equal to 80 is the price of a regular call minus the up and out call with the same barrier. So that's 4.0861 minus 0.7583, and that ends up being 3.3278. And the price of the option described in the problem is 2 times the first up and in call minus 1 times the price of the second up and in call, and that ends up being 4.5856, which is answer D. Please remember that this is copyrighted material. The problem itself comes from Society of Actuaries, so it belongs to the Society of Actuaries and is reproduced with permission, but the solution is mine. Good luck in your studies and good luck on the test.